Hello, my friends, and welcome to CSE 1322. This is going to be lecture number 9. Today, I'm going to simply give a review for test 1. There is 2 videos from this week. One of them is lecture 8, and this one is lecture 9. There's also already a lecture 10 that's posted, but that is for next week. And so some people have asked questions about that, so I just wanted to clarify what's going on with that. So today, as I mentioned, I'm going to talk a little bit about the upcoming test. Because this is a fully asynchronous class, you guys will be taking the test online, and you'll get instructions on exactly how we're going to do that. What you should expect is somewhere around 8 to 10 questions at the outside, maybe 6 at the low end. The questions are going to be comprehensive for everything that we have covered so far. So you're going to have questions that have to do with the review material that we did at the beginning when we talked about 1321, and some questions about object-oriented methods, and so on and so forth. So a couple of things to do when you're studying for this. The first thing is, over on the first year experience page, ccse.kennesaw.edu/FYE, under resources, you will find down here that we have posted old exams. So very specifically, tests 1, 2, 3, and 4 from 1322 are posted, and you can take a look at them. The format is going to be similar, although obviously not in person for you guys, so that'll be a little different, but same idea. Something to be aware of is that we have reordered the material in the class. So in this test 1, there's a reference to a bubble sort that you would need to understand, which you may be thinking, well, we didn't cover bubble sort, but yeah, that's true. We didn't cover bubble sort. It's not in here. So you really need to look at test 1 and test 2 and only the relevant material that is valid from each of those. So like this is a typical question where we have you tracing through some code and trying to figure out what's going on in there. And so, you're setting up a couple of variables, you're doing a for loop, and then we're using a print statement here to print out some information. We're doing a increment on a variable, and hopefully that syntax makes sense to you in both cases there. There is a difference between these two. If you do x++, it will use the x in the print statement, and then it will increment it. If you do ++y, it will increment it first, and then use it in the print statement. So if going into this statement, x was equal to 0, let's imagine, then this would print out x equals 0, but it also changes x to be 1 at the end of the print statement. Whereas if y was also 0, this one will actually print y equals to 1 because it does the update beforehand. So just something to be aware of on that. This is the one regarding the bubble sort where you had to write an algorithm. And again, that's not relevant here. This one is defining a 3x4 array, and we have done arrays, and you've at least had to think about multidimensional arrays, so that's plausible. Here's one where you're given some code and you have to decide which of those are not correct, and it gives you a bunch of statements that are not correct. And then down here you have defining a class for a dog, and this is a pretty common question where we would ask you to write the definition for a dog or something along those lines. You will not have the use of an IDE, so you will have to know the syntax pretty well by the time that you get to the test. So make sure that you practice, especially a question like this, what that would look like on a piece of paper without the use of an IDE that's color coding things and telling you you're being incorrect on stuff. All right, so that's what the test is basically going to look like. You can see on this one there were, how many questions was that? I guess that was 5. Yeah, looks like there was 5 questions and then an extra credit. So that's because those were pretty beefy questions. Some of them will have multiple parts in them in some cases. So the exact number I'm not committing to. I'm just telling you that be aware that you're going to have multiple questions and make sure you flip through the questions and come up with answers. Okay, so that's the logistics of the test. I thought what I would do is I would go through some information about all the different things that we have covered in this class. And before we go too much further, on the D2L site, I did make an announcement last week where I put this study guide. And if you take a look at that study guide, it has a list of topics that you should be familiar with. So 1 and 2 dimensional arrays, array lists, strings, reference parameters, calling by value and by reference, making a class, static modifiers, access modifiers, and so on and so forth. So I'm not just going to read this to you. You obviously need to go back and review this. I thought what I would do is give you a more fleshed out version of this, and I'm basically just going to ask you questions. And I'll give you some hints as to which direction to go with them, but these are all things that you should know at this point. So I have a list over here, so I'm going to keep looking over here. Just in case you're wondering what exciting thing is happening over here, it's just the list of topics I wrote down. So the first thing that we're going to do is I have here just a basic REPL for Java and C# so that I can do some base coding with you just to give you a couple of examples. All right, so the first thing we're going to talk about are primitive types. Hopefully this one is super duper easy. I'll randomly do Java. If I say int x equals 7, then that defines a variable which is of type int, and it is assigned the value 7, and life should be good. As I said before, if I then say x++, and I print that out, so very specifically I'm going to print out x. Boy, this guy is very, very unhappy with me today. If I print out x, then what you're going to see is an 8 because it does an increment. If I put this ++ in here, you'll still get 8. And I'm just going over this example real quick because, well, it's something that you should definitely understand. I'm sorry, you're going to get 7 this time. And if I change this ++ to the beginning, you're going to get 8. And again, the difference is whether or not the ++ happens before the print statement or after the print statement. So just be aware of that. All right. Likewise, you should have dealt with strings by now to some extent. So what I'm going to do is I'm going to say string. I'm going to call it my string, and I'm going to say it's equal to hello world. Stick a semicolon at the end of that, and I'm going to print out my string. And nothing magical going on there. That should quite happily print out hello world, as you would expect. Now, there are a couple of things that you might need to do with a string. So if I'm going to make another string, I'm going to call it my string 2, and I'm going to say, I don't know, happy. Yes, I have no idea why. This makes no sense. Whatever. So what I'm going to say is my string plus my string 2. All right, so you should be aware that the plus sign used in this circumstance is going to concatenate 2 strings, and the reason that it's able to do that is because there's an overridden method for plus that understands strings as 2 parameters, and it'll give you back the concatenated. If you wanted there to be spaces in there, you can certainly put in extra spaces like that, and you can put as many plus signs as you want inside that print statement. And of course, this doesn't have to happen only in the print statements. You could have made another string, my string 3 equals my string plus the spaces plus my string 2, and then I could simply have printed out my string 3 down here. And that would be an equivalent block of code. It does exactly the same thing as before. And all that's the same in the C# window. The only thing I would have to do is change that from a capital S to a lowercase s, and this exact code would work over there. All right, so that's primitive types, that's strings, it's concatenation. There's also a concept of a substring, which is something that you may have run into at some point. So I can say mystring.substring, and it can take either 2 parameters. As you can see, REPL is giving me the definition here. Either I can take a begin index or a begin and end index. So what I'm going to do is I'm going to say from 0 to 2, and I'm going to return that back into a string. So I'm going to say string answer equals that, and then I'm going to print out my answer. All right, and we're going to run that. So what's happening here is I'm taking from position 0 to position 2 of my string, and my string was hello world. So position 0, which is the beginning of the string, to position 2, that is 0, 1, and 2, gives me hello, or just HEL, sorry. So that's 0 to 2. If I wanted to know the length of the string, and by the way, substring exists equally in C# and Java, they're exactly the same, they work exactly the same. I could say mystring.length, which is how I find the length of the string, and perhaps I want to take off 3 off the end of that. So that's going to give me the string from 0 to the length of the string minus 3, which means it's basically going to chop off the last 3 letters. So there you can see I get, instead of hello world, I get hello whoa. Hello whoa, hello whoa. All right, so that is substrings, that's strings, it's concatenation, it's primitive types. I did this with int. Hopefully you would understand that ints and longs and shorts, those are different sizes of ints, and each of those has a maximum value that it can hold. Shorts can hold the least numbers, ints can hold the middles, long can hold much bigger numbers. Int can go to about 2,100,000,000, give or take. So you can look up the other numbers to see what they're doing. All right, so I'm just going to take this code and I'm going to randomly switch over to the C# window, just so that you guys can follow along over there as well. And as I say, the only modifications I would have to have done here are lowercase, 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 and it's not system.out.println anymore, it's console.writeLine. And we'll see what I forgot. String does not contain a definition for substring. That is because it is, what is it? It was literally substring. All right, well, you know what? Yep, that's exactly what I'm going to do. I'm going to Google it. It is substring, capital S, lowercase string. I was close. There we go. String does not contain a definition for length. That's because in string it is length. And I want to say there's no parentheses at the end. Yeah, I think it's a value, not a method. There we go. Okay, so some syntax differences. All right, so hopefully that gets you to there. All right, so continuing on in C#, I'll come back to Java in a second. I'm going to do an if statement. So if x is equal to 7, then I'm going to do something. I'm going to do console.writeLine, which is a print statement, hi. All right, so is x equal to 7? Do I get a hi? Indeed, I will get a hi. What did I do? Console. Okay. Well, I apparently just stopped writing, and I spelled it wrong. Fantastic. All right, this is why we have compilers. All right, so console.writeLine hi is indeed going to give me a hi because x is equal to 7. Please note, you should know that a double equals is necessary. If I had done a single equals, that is going to give me a problem because I am saying x equal to 7, and that's not a Boolean. So it even says in the compiler there equals equals is what you meant. So single equals is an assign, a double equals is a test. Hopefully that makes sense and you're good. If statements can also have else if statements, and so you can say else if x equals 8, then do something else. Yo. And that'll happily work. And then down at the bottom, I can even add an else without an else if, and I can simply say console writeLine boo. All right. Gripping code that I'm writing here, I know. All right, but you definitely should be aware that there are if statements, and you should know how to use an if statement, and you should be able to test it. And if I come up here and I set this to 8, instead of getting hi, I should get yo. If I change it to 10, instead of getting hi or yo, I should get boo, because that's what I told it to do. Indeed. All right, so that's if statements and else if statements. All right, so next up we are going to create a new method. So I'm going to say public static do stuff, void do stuff, and I'm going to take in a parameter. Let's call it int w. All right, cool. What happened? That was supposed to be a curly brace. All right, and in my do stuff, I'm going to take w, and I am going to, I don't know, I'm going to multiply by 2. All right, now, life should be good. That'll compile without too many problems, hopefully. yes. And then I'm going to come down here and I'm going to get rid of this big long if statement because it's a bunch of nonsense. And instead what I'm going to do is I'm going to say do stuff, and I'm going to pass it one argument, and the argument I'm going to pass it is x. All right, I'm just going to clean this up a little bit. And so getting rid of all these strings, I'm going to do a console.writeLine before I go in here and a console.writeLine after I come out. All right, now what is the value of x before I go into this method? Well, hopefully it should be 10 because, well, that's what I set it to, literally one line above it. After I come back from this method, what is the value of x? And the answer should still be 10 because nothing has changed. Even though I multiplied x by 2 up in this window, I didn't actually change x. It's 10 both times. So to be clear, when you make a call to a method, the value of whatever argument you give is copied over the value of this variable in the method that you are calling. So doStuffX passes the value of x, which is 10, and it is received by the parameter in the method doStuff that is called w. W is expecting to receive an integer, and indeed it got an integer, so life is good. So w is equal to 10. It comes into the code, it takes w, it multiplies it by 2, which is what that's a shorthand for. That's the same as writing w equals w plus, or sorry, times 2. But then when this method ends, this gets popped off the stack, and that is all thrown away, and we return back to here, and when we print out our x, we still get 10. So hopefully that's clear as to how a parameter works. All right, in C#, there is the concept that I could have said ref, and if I do that on both sides, then all of a sudden things change differently. So now this time what I'm doing is I'm passing, instead of just the value over, or a copy of the value, I'm actually passing the x variable. And so the w variable and the x variable are actually the same variable because of that keyword ref. And so when I multiplied it by 2, indeed it is now multiplied by 2 back in the main code because it actually is having an effect. So hopefully that's clear. Let's flip over to our Java window here real quick, and I'm going to make myself a new class, and I'm going to demonstrate this same thing. Magic number .java, and over in magic number.java, I'm going to very simply declare a public, and I'm going to call it x, public integer x, and I'm going to initially set it to 0. All right, so life should be good. That should compile without too much of a problem, unless I did something dumb. You'll note that I hit compile a lot because I do a lot of dumb things, especially when I'm flipping back and forth between languages. All right, so over here, I'm going to create a new object. So I'm going to say magic number, and I'm going to call it my magic number gets new magic number. Okay, so to be clear, I have an x here, and then I have this call to my object that I created just a second ago. So has anything happened? At this point, this will compile and I get nothing because I haven't actually done anything with anything. But now what I'm going to do is I'm going to add in another method. So I'm going to say, let's see, what on earth just happened? Public static void doStuff. And I'm going to take in a magic number, which I'm going to call x. I'll call it a, just so that it's something different. And then I'm going to say a dot x, which is the variable that's over in that class, equals 10. All right, so down here, I'm going to system.out.println, and I'm going to say my magic number. Yes, I realize I'm putting this in the wrong place. I'll fix it in a second. My magic number.x. This obviously has to happen after I've declared my magic number, so just move that down real quick. All right, then I'm going to call doStuff, and I'm going to pass it my magic number, which is my object, and I'm going to print out the x again. All right, so question for you in video land, what is the answers that I'm going to get here? for all you fun Java folks? Well, when I print it out the first time, I'm going to get the value of x in the class that was created. And as you can see over in the class, when I created it, I originally set it to 0. So life is good. I then passed that entire object up to my method called doStuff, and inside of there, I set it to 10 arbitrarily. So to be clear, the object that I created here called myMagicNumber is being passed up into this method. And then inside of this method, I'm accessing a variable inside of that object. So again, this is very, very similar to what I just showed you in C#, and it's really important that the Java folks understand this as well. While there is no keyword ref that exists inside of Java, the function and the capability is still there. You would just wrap the number that you're trying to pass around in a class and then pass the class around. And now anybody who modifies that class, or very specifically objects of that class, they will have modified the number. In order for this to work, that does indeed have to be a public integer, because if it's private, I wouldn't have access to it in main when I instantiate the objects. And it can't be static, because then everybody would be changing the same exact class variable. So hopefully that makes sense. This is the idea of passing a number by reference in C#. It is the idea of passing an object into a method in Java. So if some of that didn't make sense, then you should probably play around with this, like do something similar to what I'm doing. Just fire up your IDE, whether that's IntelliJ or Visual Studio, or just go to Replit and play around in there, kind of similarly to what I do, and see what the inputs and outputs are, because you're certainly going to have to trace a variable through a couple of method calls. All right, so I have covered formal parameters, which is what's a parameter up here inside of a method. I have talked about arguments, which is what you call it down here when you're passing it up to a method. And we've talked about pass by value and pass by reference. All right, let's do some loops and let's talk a little bit about arrays. All right, which language? I don't know. My head is going to be spinning by the end of this, but it'll be fun. Don't worry about it. All right, so I tell you what, let's just do it in the main method here. So I'm going to declare an array. And how do I do that? First off, what language am I in? I'm in Java. All right, sounds good. So the way that I do that is I'm going to say int square brackets, and then I'm going to say myArray, and then I'm going to say myArray gets new int 10. And that's going to define for me a static array. These are not array lists, just dealing with the static array of integers. And how would I access that? I should be able to say myArray at position 0 gets the number 1. And that should all compile and be happy, and I shouldn't have any problems with that. And just to prove a point, that same exact block of code, I should be able to take that and copy it over to the C# window, and life should be good. I'm not doing anything with that array, so obviously at this point, this isn't going to produce any special output because I didn't do anything to it yet, but just want to prove that syntactically that is correct in both languages. All right, this is the C# window I flipped back in case you didn't catch that detail. All right, so now I'm going to be able to use a loop. So what we're going to do is we're going to say for int I equals 0, I less than 10, because that's how big I made my array, and I'm going to say I++. And what I'm going to do here is I'm going to say my array at position I is going to get, let's say I. All right, so what is this going to do? So this is a for loop, and we're going to review that real quickly. A for loop takes in 3 parameters. The first parameter that you pass it, which is the part that's highlighted, is the initialization. I declared a variable I, which you can call it whatever you want. It doesn't have to be I, but most people will call it I or J or something along those lines. It is a type integer, and it is initially set to 0. That's all that the first statement does. Then you're going to have a semicolon. This is true in both languages. And then you're going to decide what is the exit condition of this loop. So the way you would read this is, as long as I is less than 10, we're going to keep going through the loop over and over again. And the way that we're going to move forward in the loop is we're going to do I++, which says increment I each time through the loop. If you didn't do that, then the loop would go forever, because I is set to 0 and I is 0 is always going to be less than 10, so the loop's just going to keep chugging forever and ever and ever. So you need the incrementer. So there's 3 parts to a for loop. The first part is the initialization, where you set a variable to 0, most likely, or maybe you set it to a high number and you walk backwards, or maybe you set it to whatever, but it's the initial number that you want the variable to be set to. The second parameter is the exit condition of the loop. The loop's going to keep chugging until that exit condition happens. And the third parameter is how you actually decide to increment that. So we are in Java. I'm going to system.out.println, and I'm going to print out array at position 3 is, and the way that I would get that is I would say my array at position 3. So index 3, I guess, is what I'm doing here. All right. So what are we going to get out of that? Well, hopefully we will get the number 3. That's not true. We're actually going to get the number 4. We're getting the number 3. Why are we getting the number 3? Because that's what I put into it. Okay, that makes sense. I put, sorry, into 0 I put 0, into 1 I put 1, into 2 I put 2, into 3 I put 3. I thought I had indexed it differently. All right, so hopefully the for loop makes sense. Hopefully how you access an array makes sense. If this was a 2-dimensional array, you would typically have another for loop around it. So let's do a second for loop. So we're going to do, I'm going to indent all of that, and then I'm going to say for int j equals 0, j less than 10, j plus plus, and I need my curly braces. And thank you ID, but that's not what I wanted right now. Okay, and cool. So now what I'm going to do is I'm going to say my array at position I, position j gets I. Now in order for this to have worked, I need 2 sets of square brackets. And away we go. That's going to error because I'm outputting nonsense. There we go. All right. And I can't do that, so let me just comment that guy out. Okay. 3rd time's a charm, I think. Yay. Okay. So what I've created here is a 2-dimensional array. It is a 10 by 10 array. So if I had made this 8 by 8, just as a random example, you could think of a chessboard. A chessboard has 8 squares across and 8 squares down, and of course all of the squares are filled in between. And that's what a 2-dimensional array is. It's a row by column representation of data. And so by putting stuff in, what I've effectively made, and hopefully this makes sense to you, is that because it's my array at ij, and I'm setting it always equal to I, but the j is the outside loop, then what I did was I is the row and j is the column. So what I'm doing is I'm doing column number 1 first, which is the column 0, and then I'm doing I equals 1, and I'm setting that to 1, and then below it I'm setting it to 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first column of data would be 0 through 10. And then I go to the next iteration of the outside loop, which is j equals 1. J represents the column in this case, so we're going to go through another 0 through 10 inside of here. So this statement is going to happen 100 times. It's going to happen 10 times per row or per column, and it's going to happen over 10 columns because they are nested. So 100 separate calls are going to be made. That's going to put a number in there. And hopefully that makes sense. That's how a 2D array works. That's how a loop works, and that's how you put and take things in and out of arrays. So that's the super quick. And again, all of this would work, I believe, if I had picked this up and stuck it into the C# window, which I'm going to do over here. I'm just going to override this so that I'm not making crazy, and then I think that's what I had done previously, give or take. Semicolons, because semicolons. And bleh, the name my array does not exist. Why does that's because I never declared it. I forgot to copy that line over. So let's copy that line over. It's 2 lines actually. And all right. Cannot implicitly convert type int to int. And that's because, why is that? All right. You can tell that my syntax for C# is a little bit more rusty. All right, and so 2D array, okay, you put a comma in there. That makes sense. Can you not specify the numbers? Wackadoodle. All right. So C#. Oh wow, that syntax is quite different. Well, there you go. This is what happens when you try to define something live on television. All right. Okay, so I think what that's telling me to do is that this should be 1 bracket like that, and then you can combine these in both languages. They don't have to be 2 separate statements. I just did it for clarity. So they did it like this, equals new int, and then they just gave the row column definition like that. I think it's also going to bark at me when I try to put code in there because, well, let's see. Does it bark? Unexpected semicolon. Well, yeah, that is very unexpected semicolon, really, isn't it? Wrong number of indexes. Where are we? Line 16. Line 22. Oh, yeah. Okay, so that is not how you put something in there. Gosh, how do you C# people live with yourselves? I'm completely kidding, of course. All right. I think that's going to work. No. System.console does not contain a definition for... You would think I would be able to spell right by now. Wrong number of indexes, and that's because I did the same thing in my print statement. Okay, well, this has been a painful experience, but hopefully you guys are staying along. All right, so that is your syntax in C#. Look, I'll say this as a general comment. The syntax differences between the 2 languages, I know it's real easy to get hung up on them, and you might be sitting there going, he's the professor, how can he not know this? And the answer is because I'm literally teaching in 3 different languages this semester, so I'm actually having to switch between 3. You guys are only seeing 2 of them. And the syntax, it makes sense. Like, okay, yes, I didn't know offhand that you were supposed to do a comma in here. That's a little weird to me, but I know that there would have to have been 2 parameters. So at a high level, I knew basically what I was looking for. And honestly, in any job that you were ever in, you would have done exactly what I did, which is to Google, how do you do this one thing that I'm having a hard time figuring out how to do? So don't get hung up on the syntax. That's not what's important in this class. What's important is that you understand the array and how the array works and the loop and that type of stuff. The syntax, you'll always be able to Google it. And honestly, the IDE would have told me had I actually typed it out rather than trying to copy and paste it from a Java window. All right. So that is arrays. Yeah, I don't know what else to say about arrays. Hopefully that makes sense to you guys. All right, so we're going to talk about array lists next. I'm going to flip back over to Java, and I'm going to define an array list. And before I do that, I need to include something. So array lists in Java, you have to include collections, but I don't remember exactly what it is. It's system.collections or something along those lines. There you go. I was totally close. I think I was telling you what the C# one was. So it is Java util array list. Awesome. So we're going to stick that up at the top. Otherwise, I'm going to get barked at when I try. That is not what I copied. You lie so badly. All right. Sure, just give me the whole line. I don't care. Just give me what I want. All right. I will clean that up in a second. There we go. That seems to have gotten rid of that. And goodness. Okay. All right. So now we have array lists. So down down at the bottom of my code here, I am going to define a new array list. So I'm going to say array list, and then I have to specify the type of the array list. This is Java code. Let me be clear, this is going to work slightly differently in the two different languages. So in Java, you have to specify the type. So in this case, I'm going to say it's an array list of integers, and I'm going to say gets new array list of integers, like that. And then here we are in Java, I should be able to say, it would be helpful if I'd actually given this a name, wouldn't it? My numbers. All right, so now I should be able to say my numbers dot add, and this is one of the syntax differences. It's whether it's a capital A or a lowercase a. I'm going to add a 7 in there, and then I'm going to add a 9 in there, just so I have two things in there. And hopefully I'm going to put in some semicolons because, you know, that makes sense. All right, so life should be good, and that should compile. And no, it does not. Yes, you cannot do array lists of primitive types. That is a rule in Java. So if I wanted to do this, I have to use the wrapper integer. And that's going to be true in both places. This is a rule in Java that you can't have array types of primitive types. Array types can only be of object types, and so you have to use an object. And to get around that, they give you an object that is a wrapper around each of the primitive types. It's just fully spelled out with the name, or sorry, with the first letter capitalized. So int becomes integer with capital I, float becomes float with capital F, and so on and so forth for each of the primitive types. If you had done string, this would have worked without any hassle. All right, so I have now made an array list of integers, and I have stuck two things in there. So how do I get back out one of them? And in Java, the answer is I can say get 1, and that is going to return to me an integer. So I'm going to say int p equals that, and system.out.println p. I'm going to get rid of all this other junk that's up above here just so that we're not doing 100 random things. And we're just looking at this block of code. I'll get rid of my do stuff, because my do stuff is no longer valid, or necessary at least. Okay, that's a lot cleaner. All right, so what we should get out of here is we're printing out position number 1, which should be the number 9. Hey, look at that, we get the number 9. All right, why is it the number 9? I asked for the first position. Remember, they're 0 indexed. So the 0 index has a 7 in it. The first index has a 9 in it. All right, I'm going to grab this code, and we're going to go to our C# window. And the world is going to be a fun world while we're in the C# window here, because array lists work quite differently over here. All right, so the first thing we're going to do is we're going to paste this code in, which is wrong. And I have to use system.collections. Oy vey. All right. I believe it's system.collections, but that didn't autocomplete, so that makes me think, yep, it says system.collections. So I was right. I shouldn't have doubted myself. All right, so what is different here in C#? Well, the first thing is it does not take the type in here, and it doesn't take it in here either, so the syntax actually looks a lot cleaner. There's no type listed in there. The second change is that that becomes a capital A, and the third change is that there is no get method. You simply just do angle brackets, as if it was a regular array. Like that. All right. The problem that we are going to have here, other than this being a system.out.println, the problem that we're going to have here is it's going to say, well, there's an extra random parenthesis there. It's going to say that there's a type mismatch here, I believe. Yes, cannot explicitly convert type object to int. An explicit conversion exists. Are you missing a cast? That's the error message that it read to me. So why is it complaining? Well, in Java, I specified that this was going to be an array list of integers. So it knew when I pulled it back out that this was going to be an integer, because that's what I said was in my array list. So when I assigned an integer to an integer, Java was happy with that. But over here in C#, I never specified what the array list was holding, so everything that's in it is of type object, which, as you hopefully remember, is the root object of all objects. So when I put in my 7 and then my 9, those got stored as objects. So when I pull out index number 1, I got an object. And when I try to assign that to an integer, C# complains and says, I don't know what you're trying to do here. That's an object. That's an integer. This ain't going to work. So the solution to this problem is that I have to do a cast in order to get it converted to an integer. And now it works fine. Casts are something we're going to cover later, but I just wanted you to basically understand what's happening here. By putting in parentheses a type on front of something, I am specifying I need you to convert that to integer. The good news is it knows how to convert objects to integers if they are containing a number, so life is good on that. If you ask it to cast it to something bizarre, like for example, if I had asked it to cast it to a character, then you're looking for trouble, because I put in a number and I'm asking it to cast it to a character, and it says, I don't know what you're trying to do there. That's a bucket of crazy. So don't ask it to do something that doesn't make a whole lot of sense. It was an integer, make it an integer. All right, so hopefully that makes sense for array lists. The length of the array list is accessed. I'm going to just put this back so that I don't have an error on the screen, and life should be good again. If I needed to know how many things are in there, I can say my numbers dot count, and that's going to give me back a number. So what I would probably do is either store that in a variable, or I would do something like that. And it's going to say I have 2, which is not particularly helpful. REPL hates me today, as you can tell. Let's see if it'll work now. I have 2. All right, good. So that is what that's supposed to do. So it is .count in C#. The equivalent code over here is I have, and what is it here? I think it's count. No, it's length, size. It's size, that's what it is. And that should say I have 2. It won't, because there's a missing semicolon. Have you ever thought to yourself, if the compiler is so smart and it can tell exactly where there should be a semicolon, it should just put the darn semicolon where it's supposed to be and not bug me about it? But here we are. All right, when Java decides to compile, it will have 2 just like the other one. All right, so array lists. You should know how to stick things in them, how to get things back out of them, how to see the size of them, and possibly how to iterate over them. So this is probably a great time to talk about iterating over an array list. So we mentioned the for loop earlier. There was also the for each loop, which in Java is, yes, I am looking that up on the other screen. One moment, please. There we go. In Java, it is indeed for, and I would say for int x colon the array name, which is my numbers. All right, so what I'm asking it to do is I'm asking it to create a variable called x, and I wanted to iterate through my numbers, which is this array list that I have defined up ahead. So it's going to go into the first cell of the array list. It's going to pop the value out and stick it in x. Then it's going to go through whatever code is in here, and then it is going to move on to the next cell, pop the next value out, and then it is going to keep going until it runs out of size. It automatically knows the size. I cannot type and talk, it turns out. All right, so if I do that print, then I should see the size. I should see all the values that are in there. It should iterate through them for me, and it'll print out hopefully 7 and 9 at the end of the screen. It does. It's getting a bit confusing because I've got a bunch of print statements that are happening. So I'm just going to comment those out just so that you can clearly see that that is the one that's running, that's producing the 7 and the 9. So this is a for each statement, and this can be used on array lists, it can be used on arrays, anything that you want to iterate across, this is how you do that. So I'm going to grab that guy, I'm going to bring that over to my C# window, and I'm going to do the same thing over here. It's going to bizarrely format it because reasons. All right, so the difference here is it's for each, and then it is int x in array name, if I remember correctly, and that needs to be console.writeline, which I'm tired of typing, so I'm just going to copy and paste. All right, what'd I miss? Hey, look at that. Just to clarify the other print statements that are happening above it. There we go, that's a for each loop. All right, so you should be aware that there are for loops and there are for each loops. They work slightly differently. You would use a for each loop when you're going over some collection of things, whether those be arrays or array lists or some of the other collections we're going to look at later. For loops you do when you want to do something a very specific number of times. For the next 10 times I want to do this, that's going to be a for loop. While loops you typically do when you've got some condition that's eventually going to become true or false, and a while do loop or do while loop is used when you want to do it at least once and then you want to exit whenever a condition is false. So those are the 4 different kinds of loops. You should be familiar with them. You should be able to write all of them, and life should be good there. All right, so we're coming up on 56 minutes. For the remainder of the time, I'm going to talk to you about classes because that's the other very important thing that you've got going here. So hopefully that review made sense and you have a good understanding of basic Java coding. If anything that I did in there didn't make sense, you really need to go back and actually write a couple of little examples for yourself. There's plenty of examples online. Go Google any kind of basic example for an intro C# or an intro Java class, and you will find lots and lots of examples. The quizzes have had you write some, and they've also had some code on them, so you can try writing them. And of course, the slides have code on them, so you can test yourself by writing one of those methods without looking at the slide. Just figure out what the slide was asking you to do, and then move that window away, go to REPL, and see if you can write it from scratch. You should be able to do that. Okay, so the next thing that we're going to do is we're going to talk about classes, and in this test, we're not going to talk about abstract classes or interfaces, which there are already videos posted for both of those topics, but that is not included in this test. So it's everything up to that. So you definitely need to understand how to define a class. You need to understand constructors. You need to understand how to instantiate a class. You need to understand the modifiers for access modifiers, such as public, private, default, protected. You need to understand how to make a method inside a class and how to define an attribute inside a class. You need to understand what a getter and a setter is. You need to understand how to override methods that you have inherited. For that matter, you need to understand how to inherit, and you need to understand what the static keyword does. So we're going to kick those off one at a time, and I'm going to start off by defining a class. So a class is supposed to model something that's in the real world. And looking over to the side here, I see that I am, let me see, what's a good example? I have a computer. All right, so class computer. And what kinds of things might a computer have? Well, it probably has a power state, and a power state would be either on or off. Well, that sounds to me like a Boolean. So we'll call it is powered on, and it'll be a Boolean. So I would typically say Boolean is powered on. Now, I have to specify, is this Boolean going to be private? Is it going to be protected? Is it going to be public? Or am I just not going to say what it is and hope that it knows what to do with that? The last answer is usually not the right answer. All right, so let's talk about those keywords. If I say that this is private, then the only person or the only code that can ever look at it has to be within those curly braces that I highlighted there. No one else can ever change that variable or ask what that variable is because it's private. Like its name suggests, it is mine and mine only inside of this class. If I said it was protected, then it's available to me and to anyone who inherits from me. There's some other rules about packages and stuff as well, but that's the key point. It's available to me and my children. If I say it's public, it's available to everyone. Anyone who instantiates that class is welcome to come in and change that variable. And if I say it's default, it varies from language to language. The details of that you're just going to have to look up because it is specific to each of the languages. So the key point here is In general, you always want to make everything private. Why? Because when it's private, nobody can come in and change it. The only way that they can change it is to use your getters and setters, which is why you would have them. So the computer, we are going to say its powered on method is going to be private, or its powered on attribute is going to be private. In order for me to do that, I'm going to need to say public, and I'm going to need a getter and a setter. So if I have a getter, it's going to return a Boolean because that's what the state of things are. So is on, and it's simply going to return is powered on. All right, and this is a pretty simple getter. I'm not doing anything crazy in here. And how about a setter? Well, we need a turn on, and that's probably going to be a void. It's not going to tell me anything. Maybe it needs to decide, can it successfully turn on? Because if it's not plugged in, it wouldn't be able to turn on. But for now, we're just going to say it's a void. So I'm going to say public void turn on. And what it's going to do is powered on equals true. All right, life should be good with my computer. I'm going to clean up some of the code down here just so that I'm back to a sane state. Life does appear to be good. All right, so I have successfully defined a class in C#. That code would have been very similar had I actually done it in Java. As a matter of fact, I believe that that could be copied and pasted directly to Java. It would probably ask me to put it in a separate file if I'm going to make it a public class, which is what I am trying to do here. All right, so how do we instantiate this computer? Well, I can say computer, and then I give it a variable name, which we're going to call it Dell, because that's what the one sitting in front of me is. And I'm going to say new computer. All right. Pretty much nothing's going to happen here. It complains because it's a warning. So let me be clear. The difference between a warning and an error, a warning says, I don't know what you're doing there because you made a variable, but you never actually used it. That's not going to stop anything. It did successfully compile and it did successfully run. It's just it said, by the way, I'm not entirely sure you did what you think you're doing because you did nothing. So life is good. All right. So now I'm going to turn on my computer. I'm going to say del.turn on, and nothing's going to print because I didn't actually print anything out on the screen. If I wanted to print something, then I could do that up here, which isn't really a great idea, but system.out.println, I'm turned on. Yeah, that's not weird at all. All right. And then for the Boolean, okay, so it should, what's wrong? I am in C#. I am not in Java. That is why this is not working. Apologies. All right, so it has been turned on because I called it. I'm going to change the wording of that. There we go. That's better. Kind of. Okay, so that is instantiating an object, which we call del, and calling the turn on method inside of that object. And hopefully all that makes good sense and that's not something crazy or weird. So far, everything that we did here, as I say, should be copy and pastable over to there. I'm going to try doing it here, but I think it's going to bark at me. We're going to come in here and we're going to clean all this up, and then we're going to move that main method over, and we're going to change my print statement because that always has to be changed. And then we'll see what I didn't do right. Boolean is fully spelled out in Java. And I think those are the two places. There we go. All right, so that did copy and paste just fine between the two. I'm going to get rid of this random other thing that I have over here because that's probably going to get confusing at some point. There we go. All right, so I have shown you how to define a class. Simply have the word class and then a name for your class. You have curly braces to list your code for the class in there. I've shown you how to create a private variable. This particular one is a Boolean. and I've shown you how to define getters and setters that are very specific to this particular class for turning on the computer and also for telling me the current state. So I could say if del.isOn, then, which language is this? This is C#. Console.writeLine, the del is on. And what should happen is that should say the del is on. Cannot convert method. Yes, it would be great if I put open close parentheses after that, because I am making a call to a method. All right, and it does say the del is on, so life is good. All right, and that would be the same in the other one. Obviously, it's a system.out.println. I'm not going to copy it over for you. All right, so hopefully that all makes sense, and that is fairly clear. All right, so let's make another computer. I'm going to call this one, I don't know, what is this laptop? I think it's Acer. I have no idea. Acer gets new computer. All right, so now I have 2, and I'm going to change this to Acer, and I'm going to try running it, and we're going to see what happens. And it says, well, I probably should have said the Acer is on. You note that the Acer does not say that it is turned on. So that makes sense because I never actually turned it on, but how did that all magically work? Well, I declared is powered on as being a Boolean, and the default state for a Boolean is that it is false. But that's kind of esoteric, and I probably shouldn't have relied on that. It would be really nice if I had a constructor that every time a computer was built, it automatically set the power to be turned off, so that we don't have this confusion going on. So how do we define a constructor? I'm going to call a method computer, and I'm going to simply say is powered on equals false. All right, the method doesn't actually return anything. Computer is inaccessible. Oh yeah, it's a public method. Because it's a constructor, it has to be a public method. I have broken REPL. It has officially given up on me. It has had enough of my shenanigans. Just says loading. All right. Hey, there we go. Now it likes me again. Okay, so nothing has actually changed in my output, but something different has happened. So when I created the Dell computer the first time, there was no constructor. And as a result, the default constructor was called, which does nothing. In C# and Java, all it does is it initializes variables to whatever their default state is. So in this case, it did set is powered on to false because, well, that's a Boolean. But it did nothing else. In my constructor here, I could have said something else. I could have said console.writeLine, I'm alive. And then every time a new computer is constructed, it's going to say I'm alive. We're going to see that twice, simply because I created 2 different computers, a Dell and an Acer. So the constructor gets called regardless of whether you want it to or not. There is always going to be a constructor. If you didn't define it, it's simply going to do the initialization for you. If you do define it, it's going to do whatever you tell it to do. How did it know to call this constructor? Because I passed no parameters when I made my new computer. As a result, it calls the default method, the default constructor for computer, which takes no parameters. So life is good there. All right. So the next thing I'm going to do is I'm going to talk about, well, what happens if we wanted to give every computer in the world a unique serial number? All right, so I'm going to keep track of a variable up here, and I'm going to say they're all integers. Every computer is going to get a random integer serial number. So I'm going to say int serial number. All right, now I have to decide, is this going to be public? Is it going to be private? What is this going to be? So what I'm going to do is I'm going to make this private. Because, again, nobody should be reaching in and messing with my serial numbers. If I'm in charge of keeping track of my serial numbers, then I'm going to make sure that nobody is messing with them. So now in my constructor, I'm going to say serial number equals, or serial number plus plus. All right. Now, the problem with this is that the serial number for my first computer, which was my Dell, is going to be 0. So what's the serial number for my acer going to be as it currently stands? So what I'm going to do is I'm going to add a getter just so that I can get the serial number. So I'm going to call it public, and it's going to return an integer because that's what the type of serial number is. And I'm going to call it getSerial, and it's not going to take any parameters. And I'm very simply going to return serial number. Cool. All right, so what do I get if I call getSerialNumber on each of these? So I'm going to say del.getSerialNumber, getSerial, and I'm going to print that out. And note that you can just make a call directly inside of the print statement like that, which is pretty cool. All right, and I'm going to grab that guy, and I'm going to do it again for the acer. And I'm just going to update the strings there, so it says acer, and then instead of calling del getSerial, I'm going to call acer getSerial. Okay, so to review, what's happened here is I have created a new Dell computer. I have then called getSerial on that, and I'm printing out the serial number for the Dell. Then I created a new acer, and I print out the serial number for the acer. And then I'm going to comment all the rest of this out because I don't care about any of the rest of this. And that is going to be one too many lines down. I've lost the end of the method, so I'm just going to put that in the right place. Get rid of that one. Life should be good. No, because I typed it wrong. Okay, now life should be good. Okay, so the serial number for the Dell is 1. The serial number for the acer is 1. Okay, so to be clear, each one of these variables is an instance variable. And what I mean by that is a new copy of isPoweredOn and a new copy of serial number were made at the time that I said new computer. And Dell, which is the variable that's holding that new computer, has one copy of them. Acer has a whole other copy of them. So if somehow I went into Dell and told it to turn on and off the power, that has no effect on Acer, which is very desirable. But if I wanted my serial numbers to be unique across every computer, this didn't really work out the way that I was hoping for. So I'm not saying that this is wrong. It could be that I want the serial numbers to start uniquely as 1 for every time I make a computer. But that's not particularly very helpful because if I make another acer, its serial number is also going to be 1. So I'm going to call it acer2, and I'm going to put a 2 in there, and I'm going to put a 2 in there, and I'm going to hit run, and you're going to see that the serial number for that guy also turns out to be 1. So I have 2 acers with the same serial number. Not great. All right, so how do I fix this? Well, that's where we get to the magic of the keyword static. So what does static do? If I say the word static on front of it, all of a sudden, this is no longer unique for each object. And you'll see that the Dell object got a serial number of 1, the acer object got a serial number of 2, and the acer2 object got a serial number of 3, all because of that magic keyword static. Why? Because what static says is this variable is now tied to the class, not to the object. That's what you need to remember. So because it's a class variable, every single object that's instantiated from this class does not get their own copy of it. They all share this one copy. So when the constructor got fired and I said serial number plus plus down here in the constructor, it changed the static variable, which was part of the computer. So now every computer will have a unique serial number. If I continue making them, they will all just be incremented 4, 5, 6, 7, 8, whatever number it goes up to. All right, so hopefully that makes sense as to what a static variable is. You can also have a static method, and a static method can only access static data. So I could not declare computer the constructor as being static because that doesn't make any sense. I'm accessing things that are not static in there, so it would bark at me. I can only make something static if it is accessing only static variables. So this guy could be static because he only accesses a static variable. Cannot be accessed with an instance reference, and that's because I called it with the instance, not with the class name. The problem here is that I'm always going to get a different number. So this is a bad example. I'm not going to do this because that's just going to confuse you. Hopefully the previous example made sense. All right, the static keyword is the same in Java and C#. I'm not going to copy it across because it is exactly the same. I'm currently coding in C# for the record. If I moved that over to Java, this code would have been exactly the same. Nothing would have changed. And down here, this code would have been exactly the same as well. Nothing would have changed as far as I can remember. All right, so hopefully that makes sense to you. So now you understand the difference between a class and an object. An object is the instantiated version of a class. You understand the difference between private, public, protected. You understand what a static keyword is, and you understand how to call a method inside of a object. You'll note that I was using that period when I wanted to call a method, and if it's a method, the method name has to end with open close parentheses unless there are some arguments that are being passed to it. You've seen how to make setters and getters in here, and you've seen how to instantiate the class. All right, so the next thing I'm going to do is I'm going to show you how to overload, not override, we're going to overload the constructor. So I'm going to say public computer, and I'm going to take in a manufacturer, which is going to be a string. All right, so in order to store this, I'm going to have a manufacturer. Now, should the manufacturer be a static variable or a non-static variable? Well, each object is going to have a different manufacturer, so probably should be a non-static. So we're going to say string, private string manufacturer. I think that's how that's spelled. All right, and then down here in my overloaded constructor, I'm going to say manufacturer equals manufacturer. All right, so why did I do that? Well, this is the manufacturer right here, and I took it in as a string. And what I'm trying to set is the manufacturer in the object. That's terribly confusing. So there's two ways to solve this. I can call this something else. Call it x underscore. Now life is good. It's very clear what I mean. I mean to modify the manufacturer in the class and set it to the one that I took in as an argument. The other way to fix this problem is to put the keyword this on front of the class variable, and now life is good. All right. Computer.manufacturer is assigned, but its value is never used, which is true. I'm setting it and never doing anything with it. All right, so hopefully that explains when you would use this. It's referring to something that is in the class, and hopefully that explains overloading a method. We can overload any method. It doesn't have to be a constructor. So I could have another version of getSerial that takes some parameter in. I don't have a good example off the top of my head. Turn on, maybe I take in the voltage as another version. So there might be a public void turn on that takes in voltage as an integer and then does something slightly different. And you can have more than one override. You could have, more than one overload. You could have 3 or 4 different overloads for different parameters that can be passed in. As a matter of fact, earlier in this review, you saw me calling the substring method on string, and you saw when I was typing that, it gave me 2 different options for the substring method. And that's because the substring method is overloaded with 2 different sets of parameters. In one case, it only takes 1 parameter and it does one thing. In another case, it takes 2 parameters and it does something slightly differently. All right, so that is the example of overloading, which is hard for me to remember to say. Yeah, all right, what else am I supposed to talk about? We talked about this, we talked about instantiating classes. Cool, I think we're into the heavy object-oriented stuff. That's down the bottom of my list here. We're almost there. Hope you haven't jumped off a cliff yet. All right, so where are we next? Next, we are going to take my class and we're going to inherit from it and show a little bit about inheritance from here. All right, so I have a computer and I need to think of an example real quick. So what I'm going to do is I'm going to make a different kind of computer. We'll make a laptop. Hey, that's a great example. All right, class laptop, and it is going to inherit from computer. I'm in C#, just to be clear. The keyword is a colon in C#. If I was in Java, I would say extends computer. So it's one of those two words, either a colon or an extends. All right, so now I have a class called laptop, and in my laptop class, I can now have different things. So what's different about a laptop from a computer? I don't know. I don't have a good example here because I'm making this up on the fly. All right, so laptops tend to have touchscreens. Yeah, laptops have touchscreens and desktops don't. I got nothing. All right, so here's probably a better example. All right, I will give a weight up here. So I will say it's an integer, which doesn't really make a whole lot of sense. So desktop computers tend to be pretty hefty. Laptops, they go out of their way to make them lighter. See how I'm going here? All right, so we have a weight, and we may have some methods inside of computer for getting and setting that weight. So let's go ahead and do a couple of those. Public, we're going to have, that's going to return an int, get weight, and it's going to return weight. And then we're going to add another method, which we're going to say public. This time it's going to be a void, and it's going to be set weight. That's going to take in an integer of the new weight. I'm going to do it this way just so you can see both examples, and I'm going to say weight equals new weight. All right, cool. So I have added getters and setters for my weight. All right, so down in my laptop, perhaps I might want to do weight slightly differently. So first off, I'm going to compile and make sure I didn't do something dumb. Yes, I did not do something dumb. All right, so now I might have something different about how I set the weight. I don't really have a good real example here, but let's just go with it for a moment. Somehow the way that the weight gets calculated for a desktop and a laptop might be different. So what I'm going to do is I'm going to override, not overload, I'm going to override the definition for set weight. So we're going to have public void, public override void set weight, and it takes in an int new weight. And I'm going to say I'm just going to print out so that you can see which one we're in. All right, so I'm going to come up here, and in my set weight, I'm going to add a statement so that it prints out computer weight. All right, so to be clear, we have a class called computer. It has a private variable called weight, which is not static. It's a regular variable, an instance variable. And then we have a get and a set weight method that is defined. And then we have a laptop, which inherits from computer. And then we are overriding the set weight method in here. All right. So I'm going to get rid of some of these examples down here because there's a lot of junk in here, and I just want to clean things up a little bit. And so I originally said computer Dell gets new computer. All right, and then I printed out that. I'm going to call set weight on them just so that you can see what happens. Probably weighs 100 pounds. All right, now I'm going to say computer. Actually, I'm going to say laptop. And I'm going to say Acer. It's going to be 10 pounds. I'm going to comment that out because I'm going to need a console.write line in a minute. All right, so I have created one object of type computer, which is what we defined up at the top. I called set weight, and I set the weight to some weight. But more importantly, I printed out computer weight. Then I have a Acer of type laptop where I created a new object there called Acer. And on Acer, I'm also calling set weight, and I'm passing it 10. So what you're going to see is you're going to see computer weight, which is going to happen from here, And then down here, you're going to see laptop weight because I'm calling it two different ways. I forgot a semicolon, of course. Laptop weight cannot override inherited method because it is not marked virtual or abstract. In C#, in order to override a method, the method itself has to declare that it is virtual. Public virtual int get weight. And would have been good if I had actually put that on the right one. Bada bing. All right, so to be clear here, I created an object of type computer and I called setWeight and it said computer weight. Please note that also the constructor did get called here. It said I'm alive. That constructor call happened inside of computer. Remember down here inside of there we printed I'm alive. It also set a serial number because that's part of what the constructor does. Note I never called the constructor, it just happens automatically when you create a new object. The constructor is always going to be called. That's why we got I'm alive. Then we did del.setWeight, and when we did del.setWeight, we can tell that what was called was the set weight up here in computer because it said computer weight. Everything is good. Then we created a laptop called Acer, which is of type laptop, and we instantiated an object of type laptop, which again inherits from computer, and has an overridden method of setWeight, which just prints out laptop weight. It is important to note that when I called new laptop, I instantiated a new laptop. The constructor in laptop would have fired. Which constructor, you say? You didn't write a constructor. That's right, it doesn't matter, it still fires. There is an inherent hidden constructor method called laptop, which does basically nothing because there are no parameters in here or no attributes in here, so there's nothing to initialize. So that did pretty much nothing. But it also called the constructor in computer because laptop is a child of computer. So that's why it says I'm alive again before it gives you the laptop weight, because the constructor in laptop got called and the constructor in computer got called. They both did what they were supposed to do. So if I actually print out the serial number here, and so I'm going to say console.writeLine serial for laptop. All right, so how would I do that? I would say plus Acer dot get serial. One of these days, I will remember to put semicolons everywhere. Okay, now there's something very important that you have to notice here. I called Acer, which is of type laptop, get serial. But if you go look at the definition for laptop, there is no definition for a method called get serial. So how on earth is this working? And the answer is it's working because laptop inherited from computer. All methods in computer that are at least protected are available inside of laptop. I say at least protected because they have to be protected and or public. And for me to be able to call it down here in my main, it has to actually be public. So acer.getSerial magically allows me to call that, and I am able to get the serial number. And as you can see, the serial number is 2 because I created a computer. So even across computers and laptops, which are two different classes, that static variable is still there because the static variable is inherently in laptop as well because it was inherited down. All right, so I hope this example gave you a good explanation of how to inherit from a class. Again, extends would be the word if I moved this over to Java. This would obviously be the console or the system.out.println. And other than that, I don't believe anything else changes. Oh, this keyword override is not here in Java. It would be an @override on top of the definition. And up here where I said virtual, that's not necessary in Java. Every method can be overridden in Java by default. In C#, you have to say, I'm allowing somebody to override me. All right, so that is a definition here of computers and laptops being subclasses of computers and inheritance. We've looked at overriding. We have looked at we've looked at, yeah, I mean, I think we've looked at all of that. I'll do one last thing. I'm going to scribble on the screen, as soon as I can figure out how to open my pen here, a UML diagram of what we just did, just so that you can see what the UML diagram would look like. And that is not the correct end of my pen. Oh, goodness. All right. So I have two classes defined in here. One of them is called computer, and it has a bunch of attributes. So let me go to my handy dandy little whiteboard that I keep handy in here. Come along, come along, come along, load, load, load. No, that is not what I want. There it is. Okay, sorry about that. All right, so I have a class, and that class is called computer. So we would start off by, this is an example from somebody else, so sorry about that. I'm going to start off putting on a pen, make my pen red so it's all nice and clean. All right, so we have computer. And if we go back to my code and we take a look at that, it looks like I have 4 attributes that I need to talk about. All 4 of them are private. So we have is powered on, serial number, manufacturer, and weight. So just so you don't have to watch me type, I'm going to say really. All right. Can I do more than one line in there? That would have been very helpful if I had been able to do more than one line in there. Hey, there we go. All right, so we had is powered on. I've already forgotten. Serial number, manufacturer, and weight. All right, so that's the beginning. Then we're going to have a line across, because that is the end of all of my attributes. And now we're going to talk about all of my methods. So what methods did I define in this class? Well, there's a bunch, and they were, we had isOn, getWeight. These are all public. So I'm not going to write all of these out here, but you would list every one of them in there. So isOn, getWeight, setWeight, turnOn, getSerial, the constructor computer, and the constructor overridden with manufacturer. So I'll write out the first couple just so you see it, and that's going to have a plus sign in a very large font for some reason. The plus sign is because it's public, and it was isOn. And then the second one was getWeight, and it's also public. And again, that would all be in one line. There we go. I have no idea why this font is so suddenly huge. We're just going with it. And then I'll do the computer and computer passing it an integer for the weight. All right. So other than the formatting being a bit goofy on that, that is how you do that. I'm sure there's a way to change the font there, but I'm not going to worry about it. All right. Now we then had a laptop. So the next thing that I would do is I would create another box for a laptop. And I would do the same thing again, where I would list all the attributes of laptop, which include things like, actually, I don't think there are any attributes. I think there's only one method, which is a public method called setWeight. So in actuality, the top box would be empty. This one I will fully flesh out because it's easy. SetWeight, which takes in a weight. All right. And that's really it. The last thing that I have to do is I have to specify that this guy inherits from that guy. Now, normally you would put this directly below it, so you don't have to draw a squiggly line like I did. And that's an arrow, just so that you can say that it inherits. And that is your UML diagram for what we just coded. So something to be aware of what a UML diagram looks like. It's useful when you're discussing what your methods and what your classes are implementing and how they're working. And so that's that. All right. Well, that completes everything that I think is worthwhile talking about for test number 1. Hopefully this was helpful to some of you guys, and just a quick review. If any part of this didn't make sense to you, feel free to send me an email. You know my address. I'm esully13@kennesaw.edu, ESULLI13 at kennesaw.edu. I'd really like to meet the former 12 other eSullys, but anyway, that's not important right now. You can also use detail, but it's easier if you just email me directly. Obviously, it's on the D2L shell, it's on the syllabus, it's all over the place. So send me email if you're lost or confused. You have one more office hours, which is on Thursday of this week. So you can also show up to that office hours. The times are posted in the syllabus, so I'm not going to state them just in case I get them wrong. And that is Eastern time for some of you who are not in the US. All right, and so that's going to be it for this review session. I wish you all the best of luck. I know you're going to do fantastic. And as I say, I would take everything that was in here and see if you have any questions about it, and maybe start writing some examples so that you have the ability to see how things are going and how you're able to code, much like I was able to here when I was doing these examples. So anyway, that's it from me. That's end of lecture 9. Best of luck to you all. I know you're going to do fantastic. Don't let me down. We have to beat the other sections. That's not really a thing, but it's very important for me that we beat the other sections. So don't disappoint me.